All right, welcome back. Today we are going to be talking about classes and objects in processing, or in other words, how can we make our own things in processing? And so, first off, I want to review kind of what we've covered so far. We've talked about the setup and draw functions in processing. We talked about variables. The thing about variables is we can also think about them as just storing data, right? So variables are just data. They're data that store different values. We have if statements and loops. It turns out that theoretically you can code about anything you want with just if statements and loops. You don't need any other tools besides that. The world's your oyster once you have those. That being said, there are definitely tools that we can add to make things easier. One of these is functions, which is we've talked about that already as well. Functions are tools. They're methods. They're tools that allow us to do certain things. Like a hammer or a nail gun. It makes it easier for us to do the same thing, especially if we want to do it over and over and over again. And today we're going to kind of continue along this path of learning new tools that maybe they require a little bit more work up front, but that makes things in the long run much, much easier for us. We're going to continue along that path by learning about something new called classes and object-oriented programming. And so let's go ahead and get started with that. Before talking about the concepts, I actually want to bring up my example here and start with that. So check it out. First off, if I press play, you'll see I have some bouncing balls on my screen, several of them actually. Different colors, different sizes, they start off with different speeds, things like that. But this is pretty cool, right? If you're in the 103 class, you've done this already with one ball, but now I'm just doing it with several. So that's pretty cool. Let's look at my code and let's see what I'm doing to make this happen. So, I'm at the top, don't see anything. Then here in my before my setup, so in my global space, you see, what do I have here? Well, I have a variable called b1 of type ball. That's weird. Usually I would have something like int x or whatever, is equal to 5. I have something like that where I have the type, the name, and then it's equal to some value. But here, my type is a ball. My name is b1, and it's equal to a new ball. That's weird, Okay, but I've done that for a few of these, right? Then if I go down, my setup doesn't have anything. Then in my draw, I'd said B1. Okay, well, it looks like B1 was my first ball. So ball 1, B1, dot render, B1 dot move, B1 dot wall detect. Weird. I got that for B2 as well, render, move, and wall detect for all the balls right here. It's very weird and strange. If I press play again, you see I have 1, 2, 3, 4. I have 5 balls. Interesting. So I have B1 through B5 here. I'm seeing 5 balls. What happens if I comment out all of them except for B1? Let's try that. If I press play. Okay, now I only have 1 ball. That's interesting. What if I comment out the wall detect? We're just exploring here. We're seeing how things will affect the program. So we have render, we have move, but no wall detect. What happens? Oh, I don't. I think it actually started here, and then it shot off. Yeah, did you see it? Did you see it? So it doesn't detect that it's hitting a wall anymore. If I comment out wall detect, there it goes. Woo. Okay, what if I comment out move? You see, there it is, but it's not moving. Just stays there. Weird. And then again, it probably makes sense if I comment out the render. We just don't see anything anymore, right? And so, interesting. So this is very different from anything we've seen before. We've never seen it. We've never said, hey, processing, make a new ball. Because I guarantee, if you look at the processing documentation, there's not a thing of type ball. There's nothing there's no new ball command built into processing. So, weird. What is that? So for some reason, this has made a new ball for us. And then for some reason, I can say b1 dot render, and then it displays it. And if I say dot move, it moves it. If it dot wall detect, it detects if it hits a wall. Whoa, that's really cool. It's really weird. We haven't seen that before, but it's really, really cool, right? Because if you think back to, if you're in the 103 class and you've done the bouncing ball before, you have all these if statements, you have all this stuff to control its movement. But if you had to make 5 of those, that's a lot of code you have to copy and paste and change little things about, right? So that's a lot. So this is really nice. This is not a lot of code to make all this happen. That's pretty awesome. And so this is actually what we're going to talk about today. And this is using classes to help us make multiple instances or multiple kind of copies of a ball. And so that allows us then, of course, to very easily make, in this case, 5 balls bounce across the screen. Or if we want, we can have 6 or 100 or whatever. And so this is what we're going to talk about today. You can see here, I actually have a second tab here called ball. I'm just going to glance over here. We'll talk about this in much more detail later on today. But if we look at this, you can see there's lots of stuff here. But if I look at, like, so the render bit, well, this looks familiar. You've done this to color the circle before. If I look at the move bit, well, that looks familiar. I know if you've done the bouncing ball before, you've done this type of thing to move the ball. And then wall detect, well, these if statements should look familiar to you as well. These allow you to detect if you're hitting a wall. So in this case, this looks like if you're past the right wall, flips the X speed to be negative. So you've all seen this before. Interesting. So we're seeing bits of code that you've already done before in the past, but now it's being applied to this class. Cool. All right. So let's now go back to the slides here and let's talk about this. And so a class, what is that, right? Well, a class, what's kind of cool about that, it's a type of thing that you get to define. And so if I ask you what types of things are there in programming that we learned so far, you may think back to like the variables lecture way back when we talked about data types, where there were ints, like there are int variables, there are float variables, there are strings, booleans, there's all these different types of things, right? But those are built in. Ints and floats and booleans and strings, those are built in to processing. But what if we could make our own type of thing, where it could be anything we want? Well, that's what a class is. A class is something, it's a type that you get to make, and you can make it do whatever you want. So that's why, in my example here, I can make things of type ball. Because what have I done? I've made a new type, a type named ball, and then I told processing what that means for it to be a ball. In fact, that's why this tab here is called ball, because I made a new type of thing called ball in this new tab, which allows me to make balls, which can bounce around and have a good time. There they go. And so, interesting. That's really, really cool. Now, what I want to do is start drawing an analogy here. So, a class, I'm going to say it's like a species. We'll draw this out here in the next slide or two. But it's like a species. And if we think about, well, what is a species? If we think about a deer or a dog, a cat, a fish, a whale, whatever. Well, how can we describe a species? Well, we can say the species has data. What does that mean? Well, data could mean like it has things you can measure. Things that have values, right? So it could have a weight. So if we think about a dog, let's say, right? A dog can have a weight. It is 30 pounds. So it has a weight, 30 pounds. It can have a color of its fur. It can be gray, or it can be splotchy. It can be Dalmatian. It could be, gold on the back and white on the belly. Something like that, right? It could have weight, color. It could have height. It could have, how many legs is it? Or does it have 4? So that's an int value, right? We could also say, can it swim? True or false? So it's like we have a Boolean there, right? We can say, can it swim? Well, equals true for a lot of dogs, right? Because they can swim. And so we have all these things that we can use to describe a species in general, so like any dog. I'm calling that type of thing data. And it's kind of corresponds with variables. So like weight is equal to 30. That's like a variable called weight equal to 30. It's a type of float, maybe. Color, if I said that, this isn't true, but if all dogs were gray, let's say. Maybe you have a species, you could say Dalmatian, right? So all Dalmatians are white with black spots. So that's like a color variable, right? Same thing, we got Booleans, all Cocker Spaniels can swim, right? These are generalizations, but you can kind of hopefully see what I'm going with here. So we can have data that has a value to each bit of data that correspond with variables with values that will describe this species. Okay, so class has data, that's one thing, correspond to variables. A class also has functionality. So let's think about in terms of species. Let's think about the dog. Well, what can a dog do? It can actually act out the ability to eat. So its ability to eat is a function. It has functionality. So one of the functions of a dog is it can eat. It can also walk. It can run. It can jump. It can bark. It has all these things it can do, all these different functions. That I'm going to describe or call functionality of that species. This corresponds to functions in our code. So, we have variables, we have functions. Let's think about some functions you've made so far in this course. Well, you've made move functions, you've made render functions, it will display it. You have functions to make things move. You might have things like out of the ball, where the function detects if it hits the wall, it bounces off, right? Maybe you have a function that changes the color whenever you click the mouse, right? And so you have these functions that allow things to be done, right? Things happen, there's an action going on. I'm going to describe that as functions. So we have a species. I'm going to equate that to a class. So species and class. Every species has data. Those are things with values you can give to them. I'm going to correspond to those to be variables in our code. A species, like a dog, also has functionalities. It has actions it can do. I'm going to correspond that to functions in our code. So let's draw this out a little bit more. And so let's say you're out in the jungle or the forest or whatever, right? You're just walking around, and all of a sudden this thing comes out of the bush. Whoa, it's like, wow, a new thing. You're like, wow, a new species. Cool. And then let's say I come to you and say, hey, I'm going to give you the job of describing this species. I want you to observe it and figure it out. Describe it for me. So what you have to then give me is you have to give me data to describe the species. You got to just give me variables with values that describes the species, but you also need to tell me what this species does, the actions that it does, the functionality of this species. And so if we look at this, first off, we have to name this species. We have to name this class. Remember, species and class. So if we name the species, it's going to correspond with us naming a class in processing. And so let's say we have something like this. You say, whoa, I'm going to name that a tiger Bambi. Species is going to be called tiger Bambi because, it kind of looks like a small deer, but it's like a tiger, right? It has stripes. So that means we have a species called tiger Bambi here, let's say, that you got to come up with a name because you've discovered this new species, so you get to come up with a name, just like how we get to come up with names with variables or functions. For a class, you get to come up with a name here. So let's say you get to come up with the name of this tiger Bambi. Tiger Bambi. That's going to correspond to like naming our class here, right? But then we got to say, okay, well, what data does this have? So I'll let you kind of think on this for a second, but it may have something like, just like the dog, it has maybe weight, maybe it has height and length, right? Has color, the color of its fur, maybe color of its eyes as well. How many ears does it have? Well, 2. Maybe how many stripes? In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 or so, something like that. So you have all these variables you can use to describe this. They can also have functionality. There's functions you can kind of ascribe to this new species. You can say, hey, this, I think this thing can run. It can run, it can eat, it can drink water, it can jump. Maybe it can dance, right? Maybe it has some strange functionality, right? What's cool is that in processing, when you make your new class or your new species, you get to make whatever functions you want. And so, if you're making something, you want it to make it dance, sure. You can do that. And so hopefully this analogy is kind of making sense to you. So a new species is a new class. Every species or class has data, which kind of corresponds to variables, which have values, and functions, which, functionality corresponds to functions in processing. That's something that it does, right? And so I do want to point out a difference, though, between the species and an individual from that species. Because let's imagine we discovered a new species called tiger Bambi. But, just because you have a species, there are going to be different individuals of that species, kind of like human beings. I'm just an individual of the species, Homo sapien, of human being, right? I'm just an individual of that. And so every individual may have their own distinct values. So what do I mean by that? Well, let's say we have tiger Bambis, right? The species tiger Bambi, and we have one named Bob, and we have one named Janet. Well, maybe Bob, they both have weight, they both have a variable called weight, right? Because they're both part of Tiger Bambi. And Tiger Bambis all have a piece of data called weight. But maybe Bob's weight has a value of 100, while Janet's weight has a value of 85. So even though they have the same variable, their variable can have a different value. Same thing. Maybe they both have a position variable, right? If they're on Earth, maybe it's a GPS coordinate, or you can think of it X and Y if you want to, right? Well, unless Bob and Janet are standing in the exact same spot, even though they have the same variable, which is their position variable, they're going to have different values, right? Same thing, color. Maybe they both have a color, but maybe, Janet's a little bit more kind of a golden brown, and Bob's a little bit of a darker brown, or something like that. And so there is a difference between the species overall, or the class overall, and the individuals. There's a connection there. They're not completely unrelated or anything, because, of course, the class, the species, describes what values, what variables and what functions each individual has. But you don't know the specific values of each piece of data until you get to the individual themselves. So hopefully that makes sense. I think at that point, let's actually go back to the ball example. And let's start breaking this down. Let's look at the data, and let's look at the functionality of the ball. Okay, so going back to my ball example. First off, in my Setup and Draw tab, this first main tab, nothing too strange is going on here, except I'm making variables called B1 is equal to new ball. A bit weird. But then I just say .render, .move, .wall detect. It's something we haven't seen before, but it's not too weird. But what I really want to talk about right now is this second tab, this new tab, this ball tab. So I will say, whenever you want to make a new class, you do that in a separate tab. You don't have to. It turns out it will work if you do it at the same time, but it's customary to put it in a different tab, and I think it helps a lot with organization. So usually if you ever want to make a new class, you go to a new tab. Now, whenever you do go to a new tab, it asks you what to name it. Name it whatever you want your class to be named. So like when I made this tab, I want to make a class called ball, so I named it ball. Now what that does is, in fact, you know what? We can even do this from scratch. Let's do it. So I'm actually going to go, cancel that. We're going to comment all this out. We're going to go from scratch together here. And so new tab, I'm going to call it ball. Will it get mad at me? It will get mad at me because I already have something called ball. But I'm going to just call it ball 2. All right. Let's say I want to make a new class called ball. How do I do that? Well, first thing I got to do is I'm going to say the word class. By doing that, I'm telling it, hey, I'm making a new class. And then what I'm going to do is, you can see here, I'm going to write the name of my class. So like if it was going to be Tiger Bambi, you'd write Tiger Bambi. If it's going to be, ball, you'd do ball. In this case, I've named my class ball 2, if you look at my tab. So I'm going to put ball 2. Now, a class is also basically a block of code. So whenever there's a block of code, what do you need? Well, you need your curly brackets. I'm going to put a curly bracket. Go down a little bit, put another curly bracket. Okay, cool. Now, we need to talk about some other things we need to add. Think back to the analogy between the class and the species. What do we need? Well, first off, we need some data. And what does that correspond to in terms of code? Well, data corresponds to variables. And so we're going to need some variables for our class here as well. And so now is going to be a good time where I'm going to share with you my overall structure. So I'm going to uncomment that. We're going to go back to do it from scratch so you can follow along. But I want to go through the structure here. I always do it this way. You don't have to do it this order, but I think it makes things a lot easier. I always have like a comment here that says my variables. And then I have the variables here for my class. Then I have what's called a constructor. We're going to talk more about that in a second. This helps us construct a new individual. It's almost like a birthing function, right? You give birth to a new individual of your species, but we're going to talk about that more later. But then if I come down here, I have a function section. Functions. And then I have all my functions, so my render, my move, and my wall detect. So that's what I tend to do. I have three sections. I have my variables, so class variables. I then have my constructors, which again, we'll talk more about what a constructor is later on. And then I have my functions. So I always start off by putting these comments here so it helps me organize what I'm about to do here. Okay, now what kinds of things do we need for variables for a ball? Well, if we think about what does the ball do, I'm going to comment that out. What does the ball do? Well, it's a circle. So what does a circle need? Well, a circle needs a position. So you probably have something like int x. And remember, at this point, we actually do not give these any values. Because if you think about you're describing a species, describing a class, remember, you can't say all dogs have a weight equal to 50 pounds, because that's not true. But what you can say is all dogs have a weight, but you don't give it a value yet. You don't give it a value until you go to the individual, right? So when you're describing the species, you don't give values to any of the variables yet. You just give the variable, and then when you get to the individual, that's when you give it an actual value. So that's what I'm going to do here. I'm just going to declare some variables inside my class. I am not going to give them values yet. And so I'll do that when I make an individual. But I need an x, I need a y, and if a circle, well, I know I also will need a diameter as well. Okay. I maybe also want a color, right? So I'm going to call this fill color. Again, no value yet. Let's see. I'll probably need a move speed, probably the x and the y. So this is going to make that an int as well. You can make it a float. I'm going to call it x move speed, and then float y move speed. I think that's everything we need for the variables. Trying to think. I think that's everything. I can even check here just to confirm. Color. Yeah, that's it. Cool. Didn't forget anything. Then we're going to need a constructor. I'm not going to worry about that at the moment. Let's go ahead and do some functions right now. And then we'll talk about what the constructor is. And for the functions, I'm just going to copy it. Yeah, you've done this before. You've done the wall detect and stuff like that. I'm just going to copy it, and then we can talk about what these different functions actually mean. And let's see, it's mad about, x speed. So I'm going to just rename this to be x speed to match what I already have. And then fill color, I called it a color. That's fine. Let's see if that cleared up all the errors. It sure did. Good, good, good. Now, let's take a look here at my functions. What do these do? Well, what does the render function do? Well, it fills, so sets the fill to be whatever my color variable is. Now, right now, it doesn't have a value. You know, it have a variable, but it's not equal to anything yet. That's actually what the constructor is going to do. So again, we'll talk about giving them values when we talk about the constructor here in just a second. But I fill to be whatever the color is, and then I just draw the circle. It's pretty simple, pretty straightforward, right? That's one nice thing about functions as well. I don't know if I emphasized this enough in the functions lecture, but what I really like about functions, you know, some people at first find it difficult to think in terms of functions because it's a different way of thinking, right? You're kind of taking a step of abstraction, right? But what's really nice about functions is that what I always do is when I'm trying to figure out what functions to make, I always think, okay, what's the smallest task I can do? And then I just have a function do that smallest task. And so what I tend to do, so what's nice about that, it helps me organize it because every function does only one specific task. But it's also nice because my functions tend to be no more than 10 lines of code. Oftentimes it's like 2 lines like this. And so that makes it very easy to solve problems, right? Because you're really constraining yourself to do something very small and very specific. So like I made a function here that does nothing but draw my ball in this case. Well, that's a very easy problem to solve. That's only 2 lines. And what's cool is that once I have this function, I never have to worry about solving that problem again in my head. I just call my function. It will just do the work for me. And so that's really, really nice and really kind of cool. And so this is a bit of a tangent here about why functions are awesome. But I wanted to emphasize that while we're here. But hopefully the render function makes sense. If I look at the move function, Well, it's just as simple. What does it do? It says, well, just make x increase by the x speed and make y increase by the y speed. So that's going to move our ball according to whatever x speed and y speed are. Very cool. Now keep in mind, if x speed happens to be negative, even though you're adding it, if you add a negative number, you actually will go in the the negative direction. So that will take care of things for us. Very cool. Wall detect is a bit more complicated, but it's not too bad, especially if you've done this before. If you just look at it, it says, hey, if, basically if your x position of the ball, if it's touching or past the right wall, which is the width, make your x speed negative. Well, that makes sense, because if you hit, it's mirrored for you, I always get confused. Think of this wall? Yeah, if you hit this wall, you want to flip the direction of the x. Go this way. This one does the same thing if you hit the other wall. Same thing with y's, except it's looking up and down. So it just flips the speed, makes it positive or negative depending on which wall you hit. And that's it. And so this is all the functionality that our balls need. So basically, every ball has the capacity to be rendered, the capacity to move, and the capacity to wall detect. Very cool. Okay. And that's why where back in this example here, that's why this, when I comment these out, if I comment out wall detect and no longer detected that it's hitting a wall, that's because wall detect function is the thing that actually detected if it hit a wall or not, and it changed the speed. And so if I commented that out, well, it won't do that anymore. Same thing with moving the render. So hopefully that's making sense to you. I now want to go and talk about the constructor. I was putting that off earlier. Let's now go in and talk about it. And so the constructor, what that does, I think, I'll talk about it a little bit here, but we'll just focus on the example. The constructor, what it does, I touched on this earlier, it basically births a new individual of your species. So if you have a new species called ball, let's say, you describe variables it might have, you describe some functions it might have, but none of these things have value. Like none of these variables have values yet, right? Because we're just describing the species, the class in general. But what we need to do is we need to talk about, for an individual, what are the specific values? That's what the constructor function does. The constructor function will give each variable a value to start off with. It initializes every variable. And so what we can do here is, first off, a constructor, it's also a function, but it's a very special type of function because we don't have to give it a type. But what we do have to do is give it the same name as our class. So like right now I'm going to give it the name ball2 because my class right here is called ball2. But if I look in my ball tab, my class is called ball. My constructor is also called ball. Okay. So ball2. And let's say I just want to give everything a random value. Well, I can do that pretty easily. I can just say make x is equal to, how do you do this in processing? I've been doing other languages. Is it random? Is it just random? It is just random. Cool. Make x equal a random value between 50 and 200. Let's see. So it's mad. If I look at it, it says float does not match with int. That's because I made x an int, and random function gives you a float. So what I can do, there's two things I can do. I can either just make x a float, that wouldn't hurt anything, or I can just convert this to an int using the int function. There we go. Let's do something similar with y. In fact, I might even just do the exact same spot. Okay, so now I've given x and y a value. Diameter, let's say I wanted a hard-coded diameter of 50. So every ball2, every ball with this class will be given, when it's birthed into existence, will be given a random x, a random y, and we'll have a diameter of 50. Okay, because remember the constructor, it's like the birthing function. And so, it's birthing function. I didn't think of a better term for that, but that's all I can come up with so far. And it makes sense, right? Because it's just like you birth an individual from the species into existence, and then it can do cool, fun things. Okay, so that's that. We also need to do color, X speed and Y speed. So color, I'm going to say a color, make it equal to red. No, let's do pink. So that's pink. And then for the X speed and Y speed, X speed, make it equal to, I don't know, 5. Make the Y speed equal to 3. Sure. Okay, you see, what does this constructor do? This constructor gives all my variables a value. What this does is this allows me to create an individual, or birth an individual. And so, and that kind of makes sense, right? Because if a tiger Bambi was born, it has certain data, has a weight, has a color, all this stuff. When you're born, your weight has to have a value. You can't say, well, the weight doesn't have any value yet. Well, no, like if you exist, you have a weight and you have a color, like you have these things, right? And so it would not make sense for a ball to exist unless all of its variables had some type of value. Or else it just wouldn't make sense. It wouldn't work. And in fact, processing would freak out, and say, well, oh, XP doesn't have a value, whoa, And so that's what this constructor does. And so what I'm going to do, since I have everything kind of written up to go in my ball class, I'm going to go back to ball class and uncomment it and just use that for the example. Everything's the same thing, though. I had some different random values for stuff, like a random color and random X speeds. But that's the same thing. But let's talk about how we use the constructor. So we have a constructor here. And so let's talk about what happens when we actually use it, right? How do we actually birth an object, an individual, into existence? And so that is what this is here. So remember back in my setup and draw tab, my original tab here, I had said ball B1 equals new ball. This is actually me using the constructor, because if I look at this, ball with empty parentheses, that looks an awfully lot like a function. It turns out that is a function. It is our constructor function at work here. And so what I said is ball B1 is equal to a new ball. Remember, ball is the type. That has to match your class. B1's the name. You can name that whatever you want. I could name it Bobby. You can name it whatever you want. But B1 I thought made sense because like ball 1 is one of the first balls. And then whenever you want to use constructor, you always say the word new, because you're making a new individual, a new object, and then you have your constructor. So my constructor was called ball, and so then this made a new ball. So that means that B1 is equal to a new ball. And then in your draw, if I look here, what do I say? Well, I say B1, render, move, and wall detect. I just call the functions. What I can, to call the function, to call anything that lives inside of an individual, you just have your individual name, dot, and then whatever it is you want to call. So if you want to call a function, you just say your individual name, dot, in this case, the render function. So what I'm going to do, I'm going to comment out all these other balls just for now, so we can focus on just what's going on with B1. Click play. There it is. So you can see, if I don't call the render function, let's say I comment out the render function, press play, I don't see anything. It's not there. And that's because I'm never telling it to render. If I look back at my render function here, that tells it to actually draw the circle. But if I never call the render function, I never tell it to draw a circle, so I never see a circle moving around. Same thing if I didn't have the move, and I press play, I never call the move function, so I never tell it to change the position of the circle so it doesn't move. And so the way I access these functions, I just say the individual name, the object name, the individual name, dot, and then whatever function you want to do. What's kind of cool about this is that you can also do this for the variables inside the individual. So like if I wanted to print out the x value of B1, the way I would do that is just say print line B1 dot x. Because x, if I go back to my ball class, x lives inside of every ball, right? Every ball has an x value. If I want to access that for a specific individual, all I have to do is say the individual name, dot, and then x in this case. So if I press play here, we can even see Move it way on down. You can see here, there's my my x value. Here, let me move this back up so we can kind of see. So it's going down. It's got really low. Now it's going back up. Boop. So you can see we can actually access different variables of our individual just by saying the individual name dot whatever value it is. You can do the same thing for the color. If you want to print out the color for some reason. So print out the color. That looks like a teal, so probably a lot of green and blue. So let's see. Oh, I forgot. It stores it as an integer, so it's hard to decipher. But if you converted that to RGB values, it would be whatever the color this is. So let's do one more. Let's do X speed. Click play. X speed is 3. Pretty slow. Let's see what happens when it hits the end. -3, because it hit the wall, so it flipped. So there you go. So hopefully that's starting to make sense here. Yeah, so let's say, I don't know why I would be 6 there, but let's say, let's say like ball 2 here. Right now I'm using ball 1, just ball. If you want to use your ball 2, B1 is equal to a new ball 2. If I click play, you see it's pink. I don't know if you remember, if I go back to my ball 2 class and look at the constructor, I told it that for all colors, make it pink. Give it a random X and Y, but give it hard-coded diameter, hard-coded color, hard-coded speeds. Okay, so press play. It's pink, same size. Press play again. Pink, same size. Press play again. Pink, same size. Okay, cool. What if I go to ball 2, though, and I make it blue? How will this affect things? Well, now if I press play, B1 when it's made, it should be made to have a blue color, because that's what we told it to do in the constructor. And here it is. And so you can see whatever you put inside this constructor, these are going to be the starting values that your individual will have when you first make it. Okay, cool. So I'm going to go back to just using ball for now. But something I do want to point out is that you can actually have more than one constructor in your class. So what I mean by that? So if I look back at my ball, you see I have this class with nothing in the parentheses. There's no inputs. There's no parameters for this constructor function. And what does it do? Well, it gives every variable a value. But I just made them all random, right? If I scroll up just a little bit, you'll see I actually have another constructor. The reason you know it's a constructor is because it has a name that matches the class. So they're both, the class is called ball. And if the function's called ball, then it's going to be a constructor. But this function, this constructor, it actually has some parameters. Now, what parameters does it have? Well, I call this temp_x, temp_y, temp_d, and temp_color. Whoa, weird. What do these do? Well, if I look inside my constructor, we can see what they do. All I said is, hey, whatever temp_x is, make x equal to that. Whatever temp_y is, make y equal to that. Same thing in temp_d. Whatever temp_d is, make d equal to that. Whatever temp_d is, make the color equal to that. And then for the speeds, I made them random, which is fine. So what this allows us to do is have more control over what data the individual has using this constructor. So let's say if I go back to my setup and draw, these constructors with no inputs, they'll just make some random stuff, which is fun, which is cool. But let's say I want to be very specific. I want ball 1 to be a very specific position, very specific size, very specific color. What I can do is I can use this constructor instead. How do I use this constructor? Well, I just need to make sure that I give my constructor 4 inputs. That's how processing tells the difference between different constructors. It looks at the number of parameters in the parentheses. So this one has 4. This one has 0. So what that means is that I can make a constructor, or I can use a constructor that has either no parameters or have 4. If I go back to my Setup and Draw tab, my original tab, these all have 0, and so it's fine with that. But you see, if I give it just one value, it's mad. It says, what the heck is this? The reason it's mad is because I don't have a constructor defined that takes in only one parameter. I have one that takes in 4, and I have one that takes in 0. So I need to make sure that whenever I use a constructor, I have it matched with that. So let's say I want to use this one, the one with floor parameters. I need to give it an X, Y, diameter, and a color. So for the X and Y, I'm just going to say 50-50. That's fine. Diameter, let's start off at 100. And for color, let's give it red. 255, 00, do. And then down here below, I have everything coming out except for B1, so we'll only see B1. So let's see what B1 looks like here. It's red. It started off at that position. Cool. Let's now make it pink. You see, by just changing the value that I used in the constructor, it actually changed the color of the ball. So how did this work? Well, if we look at this, I use this constructor. So when processing sees this line of code, it says, okay, you're using this constructor here. So it goes into where the constructor was defined, which is here, and it replaces these variables with whatever values I gave it here. So I use 50, 50, 100, pink. So it said, okay, make temp X 50, temp Y 50, temp D 100, temp color pink. And then it made X equal, in this case, to temp X, which was 50, made Y equal to temp Y, which is 50, made D equal to temp D, which was 100, and then A color, it made that equal to pink. So A color is now equal to pink, which means that when the render function was called, it filled it be A color, well, A color was defined as pink, so it made it look pink. And so the benefit of having parameters inside the parentheses of your constructor is that it gives you more precise control over the variables and data of your class. If you don't care, if you just want it to be random stuff, you can do something like this one, which has no parameters, but it just makes everything a random value. You can do that if you don't really care. You just want something to happen. That works great. But if you want something with very specific values or very specific color, you can use this constructor to make that happen. And what's kind of cool is that let's say I bring ball 2 back into this, is just because I made ball 1 pink doesn't mean I have to make ball 2 pink. I can make ball 2 start at the right side, or excuse me, the right side of the window. So I could say something like started at 1,000, and let's say at the bottom, so I don't know, 600. Make it small, so size 20, and make it green. Do something like that, or press play. You can see there's my B2, and then there's my B1. Let's see. Oh, sorry, 1,000. I want to start at the right side. There we go. Okay, so I have my pink and I have my green, and you can see I have very precise control over how these started. If I press play again, you'll see they'll start in the same spot, they stay the same size, and they have the same color every time. And that's because I'm using this constructor here, which uses these parameters that I give it, so it allows me to have very precise control over this. And then again, if I uncomment my code down here for balls 3 through 5, well, balls 3 through 5 right now are using the constructor that does not have inputs, so that means it's using this constructor. So this constructor is going to just give everything a random value. So if I press play, you'll see there's my pink and my green, so there's my ball 1, ball 2, but 3, 4, and 5 are like different shades of green this time, which is kind of interesting. If I press play again, see now there's like purple and a yellow, and similar green here. Press play again. Brown, blue, and like a pink. You know, it's going to be random and different every time. They're different sizes every time. And so that's because I'm using this constructor. So anyways, you can use whatever you want depending on what you're trying to do. But hopefully this is starting to make sense to you. And just to review, we'll go back to the slides. What do you need to define a class? Well, you need to define it in a separate tab, and you need to do 3 things. There's 3 different parts. You need the variables, the data for that. You start off by just declaring those at the top of your class. You don't give them values yet. You only give them values in your constructor, which is the second thing you need to do. All the constructor needs to do is it needs to give every variable a value. If it does that, it does its job, you're good to go. The reason you need to do that with the constructor is because the constructor is responsible for giving birth, for creating an individual or an object of this class. And so, you know, if something's being born, something's being created, boom, you know, if a human being's born, all bits of data have a value, right? It has a weight, it has a color, it has a height, it has eye color, it has all these things, right? And so it doesn't make sense for something to be created and one of those not to have a value. So the constructor function has to give every variable a value. You also need functions for that class. That's what allows the object to do different cool, fun things like move around or detect a wall or whatever. To access the variables or functions of an individual, all you have to do is you just got to say your individual name dot whatever it is you want to access. If it's a variable, you just put the variable name. If it's a function, you just put your function. But remember, a function always has to have parentheses whenever you call it. But this allows you to access any function or any variable that lives inside an individual. And that's useful because if you want to render B1, all you got to do is say B1.render. You just access the render function inside of B1. If you want to move B1, well, you just got to access the move function inside B1. You do that by saying B1.move, and you're good to go. So hopefully that makes sense to you. So if you have those three things, the variable / data, the constructor, and the functions, you're good to go. You can then define individuals. You always do that in the tab with your setup and draw. That's where you kind of make individuals, and then you have them render, and you have them do stuff. You do all that stuff in the setup and draw tab. So, here's a very, very, very basic template, but I showed you the bottle example. I think that has more detail for you. And so that's all I really want to say today. But a little challenge I have for you is to make a bubble class, which will allow you to, you probably have done this in a previous assignment, but have it where you can make some bubbles. They're just random circles that spawn at the bottom. They rise up. When they hit the top of your window, they pop, and they start back at the bottom and move back up. I have a constructor with no input parameters, and so they're just made all the variables random. And you see, to make this happen, I named them bub1, bub2, bub3. They're a type bubble. And I just say render each one, move each one, and then reset each one. The reset function makes it so when it hits the top, it resets back to the bottom. And so a challenge for you is make a bubble class that makes all this work. So think about what variables, what bits of data does a bubble need? What functions does it need? And a hint is, of course, these functions straight up, right? You also think about how do you want to make the constructor? Do you want it to have random values? And in that case, you don't need any input for your constructor. But if you do want to be very precise about it, if you want to have a lot of control over the color or the size, let's say, maybe you put some inputs or parameters into your constructor there as well. So that's my little challenge to you. Good luck with that. And thank you so much for your time. I hope this was helpful to you.